right. So, solving linear systems by substitution. Last week, we learned what a linear system is. The ones that we're working with have two equations with two variables, typically x and y. And we looked at how you would solve them with graphing already. So if you graphed two lines and they ended up intersecting in one spot, we said there was one solution, and the solution was the ordered pair that represented where they intersected. Okay, that x and that y value were the two numbers that make both equations true. If we graph those two lines and we ended up with parallel lines, then we said there was no solution because there's nowhere that the lines intersect. So there's no solution. If we graph both lines and they ended up being the same line, they coincided with one another, we said there was an infinite amount of solutions because they intersect everywhere. So that's a visual way to approach solving systems. I'm going to teach you a different way to solve systems today called substitution. And there's actually three methods altogether. So we'll learn one more later this week called elimination. But today we're going to learn the substitution method. And so if you think about substituting, you might remember seeing something where you have an expression like 3a plus b. And then they tell you a equals 1 and b equals 2. And evaluate the expression. And you have to substitute the values in place of the letters. Okay, so we're going to be substituting. So that's the same kind of idea today, and that's going to be one way we can solve these systems. This is 11.2. How can you solve a system of linear equations by using substitution? Learning goal. This all sounds very redundant. I can determine the solution to a system of linear equations by using substitution. Here we go. So these are your steps to solve by substitution. The substitution method is used to solve a system of equations by solving an equation for one variable and substituting the resulting expression into the other equation. Okay, so there's three steps. Step one, solve one of the equations. Remember, you're starting with two equations, so you pick one and you solve it for one of the variables. Typically, you have x and y. So it might be easier to solve for x or it might be easier to solve for y. It doesn't matter. You just pick one equation and you solve for one of the variables. Step two, you're going to substitute the expression from step one into the other equation that you didn't choose. And then you'll be able to solve that equation for one of your variables. Step three, substitute back into one of your original equations to find the value of the other variable. You're going to see what this looks like, so it'll make more sense. But these are the three steps to solving the substitution. Okay, this is a pair deck here. It says in the system of linear equations shown. So right here, you can see there's a picture of linear equations. Two equations. First equation, y equals 2. Second equation, x plus y equals 6. It's okay that this top equation doesn't have an x in it. That's not necessarily something that has to be true, but we can't have, you're not going to see more than two variables. Okay, so altogether we only have x and y. And so we're looking for values of x and y that make both of these true at the same time. Well, for y to equal 2, the only thing y could be is 2. Y equals 2, it tells us that. So in this case, this is a type of system where we're already showing that it's solved for one of the variables. Y is 2. And then the second equation, x plus y equals 6. Well, the substitution process means I substitute the value of one of my variables into the other equation. So if I take x plus y equals 6 and then replace the y with what y is equal to, 2, we get x plus 2 equals 6. And then I can solve this and figure out what x is. So you're going to type me a number in your Pear Deck tab. What do you think x equals? x plus 2 equals 6. What does x have to equal? So go ahead and you're going to just click on your Pear Deck tab and you're going to type a number. For that to be a true equation, what value does x have to equal? What number plus 2 equals 6? I have 5 out of 16 responses, 6, 7 out of 16 responses. Just type a number. What does x equal? I have half of you that have responded. X plus 2 equals 6. You know how to solve equations like this. You're just going to do the same thing to both sides of the equation. Subtract 2 from both sides, and then x equals, what's hiding under my face? Let's see. 4 is the overwhelming winner here, and that is correct. The answer is, in fact, x equals 4. Right? So at this point, I now know that y is 2 because it was given to me in the beginning, and I know that x is 4. So that's the solution. The solution is what x equals and what y equals, and I write it as an ordered pair. Because if I was to graph these two equations, they would actually intersect at the ordered pair 4, 2. Okay, so that last example I just showed you guys, that was a simpler example. Substitution works with any system that you might have, but it's not always as simple. So if you're given a system of equations and you're not being forced to choose a way to solve it, if you get something that looks like this, using substitution is a very easy way to solve this system. It's quick. See, that was all we had to do. Just like do, done. Now here, these equations are more complex. It's a system. We have two equations, x, y, the same two variables show up. And so we want to solve this system by substitution. So we're going to go through the steps, which I showed you here. There's 3 steps, okay? And have like Bitmojis to help you remember. Okay, so step 1, isolate a variable. You pick one of the equations and you pick one of the variables to isolate. You literally have 4 choices at this point, because you either pick the first equation and then you pick x, the first equation you pick y, or you pick the second equation you pick x, or you pick the second equation you pick y. So there's 4 choices, but some choices are easier than others, okay? And to solve for a variable, you want to choose a variable where the coefficient is 1. So both the y's terms in both equations have a coefficient of 1, or the x terms have a 3 and a -2 that we'd have to deal with. So we're going to just pick the first one, 3x plus y equals -3. I could have also picked the second one. It doesn't matter, but pick one and isolate a variable. It's easier to solve for y, so I'm going to solve it for y, which means I have to move this term of 3x, to the other side. So if I subtract 3x and subtract 3x, y is then isolated, and then -3x minus 3, I have to write it out this way because these are not like terms. Okay, so we just write them next to each other. That's step 1. Step 2, substitution. Okay, it's called a substitution method because we substitute a lot. So now that I have y written out as equal to an expression, y equals all this stuff here, then I can use the other equation that I didn't pick, which was -2x plus y equals 7. So I write it out, except though when I come to where the y would be, I don't write y, I substitute y for what y is equal to in the last step. Y is equal to negative 3x minus 3. So instead of writing y here, I'm going to write negative 3x minus 3. The reason we do that is because now I have an equation with one variable. The only variable I have is x. It's in different places, like I have an x term here and an x term here, but that's okay. I can solve an equation when it's in one variable, like it is here. So to solve this equation, these parentheses are just like placeholder parentheses. They don't need to be here. So if I drop those, negative 2x plus negative 3x is negative 5x minus 3 equals 7. All right, so we're going to combine like terms. That's what happened. And then we're going to add 3 to both sides because that's a constant, that's a constant. So if I add 3 here and add 3 there, I end up with negative 5x equals 10. Last step, divide each side by negative 5. So x is negative 2. Okay, so I know now, I know what the x coordinate is. X is negative 2. I still have to figure out the y coordinate. And so we substitute again. We're going to substitute the value that we just found, x equals negative 2, into one of the equations and solve for y. It does not matter what equation you choose. You could choose this one. You could choose this one. You can even choose this one if you wanted to, which has y already isolated, which I think is a good choice, but you choose one. This time we're just going to take the first equation, replacing x with negative 2, substitute the value of x into the first equation, simplify it. 3 times negative 2 is negative 6. Add 6 to both sides. Negative 3 plus 6 is 3. And now I know that y equals 3. I know x is negative 2 and y is 3. So that means I know the solution. Negative 2, 3 is the solution. But here's the really cool thing that I'm going to show you today that you're going to like. This slide should have Desmos open for you. I go check on GoGuardian. Yes, so if you go to your Pear Deck, you're not in it right now, go to your Pear Deck. It's a split screen. And so I have Desmos.com calculator open for you, which is really nice because we're going to use that to check our work. So let me open up this to show you. All right, so the way you type equations into Desmos, if you come back to our Google Meet, where did our Google Meet go? Here it is. Sorry. Okay, right here. Oh, I found someone. They're lost. They need to come join our meet. Okay, so I'm going to type into this blue box the first equation, which is 3x plus y equals negative 3. And it graphs the line of that equation for me. It doesn't matter that the equation I typed in is not in slope-intercept form. It doesn't need it to be in slope-intercept form. It's in standard form. It's fine with that. And then just click below and you'll get a new area to type again. I'm going to type the other equation. Negative 2x plus y equals 7. And it graphs the second line for me. Now, in this picture, I can see these two lines do intersect in one place, at one point. And the coordinates of the point that they intersect, they better be what I figured it out to be with the substitution method. It better be negative 2, 3. And so right here, if I hover over it, or even if I click, -2, 3. So I know I did it correctly. Okay. So that's an example when there's one solution. Say there was no solution. What would that look like? So last week we talked about if we have two graphs that are parallel lines that never intersect, there's never a point of intersection, there's never a solution, there's no solution. It looks like this. But what does it look like when you use the substitution method? So this is showing the substitution method here. It's done very quickly. They're taking the first equation and isolating the variable y by adding 3x to that side. So that's why we get y equals 3x plus 12. Then the second step of substitution is to write out the second equation, 6x minus 2. But instead of y, we replace y with the other thing y is equal to, 3x plus 12 equals 18. And then we're going to solve this, okay? We're still in step 2 where we're solving this equation, figure out what x is. But what happens is when you try to simplify the left-hand side of this equation, we're going to distribute 2 with 3 and get 6x, so 6x minus 6x gives you 0x. The x's just drop out and disappear. So when that happens, when your variable term cancels out and disappears, you're going to end up with one of two things happening. You're going to end up with a constant equal to a different constant. -24 equals 18. They're not the same number. This is nonsense. This is false, so we say no solution. The other case, here's another system. -2x plus 14y equals -28. X minus 7y equals 14. So if we start solving this with substitution, well, I need to take one of these equations and solve it for one of the variables. You look at the coefficients, you have -2, 14, -7, 1. If you have a coefficient of 1, you want to use this equation and solve it for that variable. And so that's what they did here. X equals 7y plus 14 because we add 7y to both sides. Okay, once it's solved for one of your variables, that's step 1. Step 2, substitute. So choose the other equation, and then when you write it out, instead of putting x, you put what x is equal to, 7y plus 14. Now in this situation, as I start simplifying the left-hand side, -2 times 7y is -14y. So that term and this term, they add to 0 and our variable term disappears. And now we're left with a constant that's equal to a constant. But these are the same number. -28 equals -28. This is a true statement. And when that happens, we say there are infinitely many solutions. Because what that means is that these two equations are actually the same equation. And when you graph them, you're only going to see one line because they are the same line. Okay, so just kind of wrap up, what did you learn today? All right, so I'm gonna put this in student paste, and I'm gonna give you 4 minutes just to do this last slide, and then we're gonna move on to Delta Math. All right, so you guys are doing the last slide for about 4 minutes. Let me find you a timer.